Okay, so we have a spherical iron ball centimeter with a diameter of 8 centimeters. And then we have a layer of ice forming on the outside of that. If the ice melts at a rate of 14 mLs per minute, okay, so I had to look this one up. For sure we know that liters, milliliters, is a type of volume equation, okay? So that's our dV over dt is equal to 14 milliliters per minute. Now, one thing that they said in the notes was that 1 milliliter is equal to 1 centimeter cubed. Okay, so that's helpful when it comes to our units later. But this is our hint right here. That's one of our hints. And our volume equation for a sphere is volume is equal to 4 over 3 pi r cubed. Okay, from the top view, here's our iron ball, and then there's a layer of ice on the outside that's slowly melting away. So we're going to say that's going to be our radius plus a little bit of x gives us the full radius of the sphere. And we know the r right here inside is going to be 4 because that's half of the 8. So our r value is going to be 4 plus x for our full sphere. So the volume is 4 over 3 pi 4 plus x cubed. Now, to figure out what they want us to do, they want to look for how fast is the outer surface area, okay? How fast, so surface area. So they're looking for the derivative of surface area when the ice is specifically 2 centimeters thick. So the x at x equals to 2 centimeters. Well, in order for us to get here, we need to figure out what dx dt is. How do I know that? Is because if surface area is equal to the equation 4 pi r squared, to find ds dt, well, we'll just keep it like that, is equal to 4 pi 2 r d r over dt. The problem here is that since this is an r and we're using x here, it's actually best to switch this to say 4 pi. We said r is actually 4 plus x in our version squared. So if we take the derivative of this guy, this would be instead 4 pi times 2, 4 plus x, and then dx over dt. Because the derivative of 4 and derivative of x, that is 0 plus 1, and then dx dt. So we can glean from this. This is what we're looking for. We can find this, we have this. So that's what we're looking for in starting from the volume, because they told us what the change in volume was. 14 is equal to, oops, sorry, we haven't taken the derivative yet. dv over dt equals to, bring down the 3, cancels out the 3 on the bottom, 4 pi, 4 plus x squared dx over dt. We know what change in volume, we know what x is, so we can solve for dv dt, so we can plug it in over here. So plugging in x is 2, that's going to be 6. 6 squared is 36. 36 times 4 is 120, 144 dx over dt. We know dv dt we said was 14. So let's move it out. Dx over dt is equal to 14 over 144 pi. Okay. Now, to find our final solution, our change in surface area, we just need to plug in ds over dt is equal to 4 times 2 is 8. 4 plus 2 is 6. 6 times 2 is 48 pi. And then we're going to plug in our 14 over 144 pi. The pi's divide out. And then this is 4 times 12. 12 times 12. The 12's divide out, leaving me 4 and 12. That becomes a 3. So we're left with 14 over 3, I think. And that's our answer here.